Hello everyone, welcome back with another video on concepts with Arish. Today we are gonna review chapter 10 really very quickly so you can get all the basic ideas, and we are also gonna practice some possible questions at the end. So if you have any confusion regarding Boolean logic, like logic gates, truth table, logic circuits, Boolean expressions, then just watch the video till the end and hopefully all your concerns will be cleared. So, chapter 10, starting with this one. First of all, the basic concept that you have to understand in order to solve the possible questions, you have to know that what are the basic six logic gates are. There's like a not gate, and gate, or gate, NAND, NOR, and exclusive OR. Okay. Then you have to draw their logic symbols and you have to draw their truth tables. You have to understand these two things. Then you have to know how to create a logic circuit. Okay, from a problem statement, a logic expression, or a truth table. Okay, how you can do that, how you can complete the truth table. Okay, if a logic circuit is given or expression is given or a problem statement is given, how you can make a truth table out of it. Then again, writing a logic expressions, if the logic circuit is given, truth table is given, or a problem description is given, how you can make a logic expressions out of it. And then we will apply all this concept to the past papers questions. Okay. So first of all, you just have to understand what a logic gate is. Logic gates are an electronic circuit that uses binary inputs like zeros and ones to produce an output binary. Okay, and thousands of logic gates combined form a circuit inside computer SSDs and control devices. Okay, so first of all, logic gates, a single electronic switch takes one or two binary input and produces one binary output. Either it takes one binary input or either it takes two binary inputs. Okay, and it gives you a one binary output always. Okay, then you have to understand the logic circuit. Multiple logic gates combined together to perform a specific function, and same way, if you list all the possibilities in one form, then it will produce you the truth table in there. Okay, so number of the rows in the truth table depends upon if they're like two inputs, then they're like four rows, and if they're like three inputs, then they're like eight rows. Four inputs will make 16 rows. But again, until in your syllabus, there's one like three inputs and eight rows are there. Okay. So again, this six standard logic gates are given. Okay. Not gate is you took the input as one. Okay. So output it will produce you as a zero. And logic notation is given as x is equal to not a, and in a boolean it is represented with a bar on the top of the input that you have taken. Okay. For the second one is a AND gate. Okay. For the NOT gate it just flips it. Okay. For the AND gate it takes two inputs. Okay, that's important. You remember rest all of them take two inputs. Okay, and output is only one when both A and B are one. So if both of the inputs are one, then you can consider it as a one. Okay, otherwise it will always produce a zero. And it is logic notation is written as A and B, and Boolean algebra is A dot B. For the OR gate, you have to understand like output is one when A or B both are one. A or B or both are one. Okay, if either A is one, or it will produce one as an output. If B is one, then it will produce output as one. Or either if both of them are one, then it will also produce one in the output. So that's the condition. So A or B is the logic notation, and A is represented by plus symbol. So A plus B is the Boolean algebra. NAND gate is when you combine the AND gate and the NOT gate, so it will work simply as it is. Okay, so it will go simply, first of all it will apply the AND gate, and then at the end whatever result you will get, it will go on with the doing the flipping it the answers, and that's how you produce a NAND gate. Same goes for the NOR gate. NOR gate is basically sorry, the symbol over here will be like completely, the bar is on top of all of that, not just on the side, and same way it goes over here as well. Okay, so it goes here as well. Okay, not just on the side. Okay, so now for the NOR gate, it combines NOT gate and OR gate together. Okay, and that is also given in the same way. You will first of all do the OR, and then you will flip the answers that will give you a NOR gate. Exclusive OR is a little bit different. Okay, output is one when both inputs are different. If they produce a different input, okay, if both inputs are different, either 0 1 or 1 0, then it will produce you a 1, otherwise it will always produce a 0. Okay, So and it's represented as XOR, and it is with a Boolean algebra symbol. It's plus in a circle sign. Okay, now the gates are given. Okay, and for truth table you can see over here just 0 1 and 1 0, so they're flipping it. For the AND gate you can simply see that like whichever have got both are ones, okay, it is producing 1, otherwise it is always producing 0. Okay, for the next one there's like a OR gate. OR gate is like if any of them one is 1, so only this one have got both zeros, that's why it's producing 0, otherwise this one have got 1, so it's producing 1. This one have got 1, so it's producing 1, and both of them are 1, that's why it's producing 1. Same way, if you're going with NAND gate, again you will do the and then you will flip it. So that's how in the AND gate we were getting all of these are like zeros, and there was 1 over here. Now they just flipped it. So that's how the NAND gate works. And see, okay, same way NOR gate is the, again we have taken OR. It was actually 0 in the 0 and triple 1 was in the OR gate, but now we are flipping it again in order to get the NOR one. So in order to get the NOR, it will give you this as the final answer. Now the next one is the exclusive OR. As like only whenever they're different, 0 and 1 they're different, so they're producing 1. 1 and 0 is different, so they're producing 1. Otherwise, when it become 1 1, or either become 0 0, so it will give you a 0 and 0. Okay. So basically, if you just like a quick memory aid, you can simply go with that. Not is flip it, add must be 1. For and it must be both must be 1. For or at least 1 is 1. For NAND, not and combined together, nor is not and or combined together, and XOR is like if they're different, then they will produce 1. Okay. So first of all, now the question comes out that like how you can make a trace build and trace. Okay, logic circuit. So first of all, there's like a simple question given over here for you. Okay, they are going on with like first of all, it's like P, A and B. They are producing the P, so you're going A and B. You're doing A and B together. You're applying the AND over here. So if any both of them are 1, then it will produce 1. Only these two are 1, so it will produce a 1 over here. Okay, and then we have got B nor C. So again you have to go or, and then you have to go on with the not of that, and then you will produce the answer. So first of all you will go with like B or C. Okay, and then you will go flip it, and that's how you will get the final answer like this. And then there's like R as well. Okay, now you're combining all of them together. Okay, it's going with R XOR C. So R is here and XOR C is here. You have to do the exclusive OR. If both are different, then it will produce 1, otherwise it produce 0. So that's how they are getting. Okay. Now, again, coming back to another type, that's basically writing logic expression from a circuits. Okay, so writing logic expressions from a circuit is basically to make a circuit out of it. Let me see if I can draw it over here as well. Okay, and yep, what they're asking for, we can go in such a way that it says get A and B. Okay, so first of all I will draw like A over here, then I will draw like B over here, now I'll go C over here. So you can see A and B are getting AND together. I will take two values from here and then I will join them together and I will do the AND. AND is represented by a D symbol. Okay, then gate 2 is B or C, so I'm gonna go with like doing OR between C and B, so it is represented by like a fish type symbol. Okay, it goes like this, and then they are combining both of the gates together by going A and B or C. You have to do their outputs as exclusive OR. So if you take their outputs over here like this, it's you can call them as like this one was like a gate 1, this one was a gate 2. Now you get combine them together and do the exclusive OR. Exclusive OR symbol is like a one bracket, another bracket, another bracket, and then like this. So yeah, like this way. Okay, so it will produce you the exclusive OR, and that will give you the gate number 3. And that's how that it's being done it. And another question is given. If you want to practice it, you may. And yeah, that's it. So now moving on further from building logic circuits from expressions, you have to build logic circuits from the expressions. Okay, so what they are basically doing over there, they're telling you you have to do the first solve the first part, then the second part, and then you have to combine them together, and that's how you will get your final answer. Okay, and then you have to make logic expressions from the truth table. That's really important. Many of the students get confused on that one. Basically what you have to do, you have to identify the ones given in there. Let's say first of all you identify the one, there's only one given over here. Okay, so you have to identify that, and then first step is like yeah, first step is like simply identify it. Okay, identify the rows that have got x as 1. Then you have to join them their inputs with, like, I will go with like a and B. Okay, so A and B, this one is A and B if they are producing 1, and whichever is a 0, negate it. So I will go like this. So it will go like A naught and B. Okay, over here it will be actually be written, because if you want to written in a Boolean logic, then you can go with like A naught dot B. Okay, so that is producing a 1. Okay, otherwise if you write it in a different way, it will become not A and then and B. Okay, if you there's a little bit confusion, don't get confused in there, because if you would apply this not over here, okay, then it will produce a different result. It will be NAND gate. It will not be a not an AND. Okay, so first of all you have to do not A, and then you have to apply its answer with the AND B. Okay, that's how it will produce your final result, and it's done this way. Okay, now going back to the questions from the book, there's like a questions given in this. They give you alarm system. You, for this you have to understand that like one stand for on. Okay, one is equal to on or yes. Okay, or high. Okay, and 0 always stands for off or no or low. Okay, so these are the terms that are being used over here. Okay, so they are giving an alarm system. Alarm X sounds if A is on and B is off, or B is on and C is off. Okay, so they are, what they are simply doing, A is on, which means it's a 1, and B is off, it's a 0. So what we have to do, we have to go with like A and B is off, so I will put a bar over there. And then I have to, what I have to do, I have to go or on them. So plus, and then B is on, so B will be like a 1, so I don't have to negate it. And is and as it is. Okay, and C is off, so C bar. Okay, so that's how I have gotten the expression. Once I have gotten the expression, I can make truth table out of it, I can make circuit out of it. So they all are related to each other. Okay, so one of the practical example is also from the textbook. It simply says the parameters are like turbine speed, symbol S, and it's 0 means when it's like less than 1000, and 1 means like greater than 1000. So for the bearing tab temperature, it's like T, and less than 80 or equal to 80 is like 0, and greater than 80 is equal to 1, and less than or equal to W, like wind velocity, then it's like 20, it's like a 0, it's like off. Okay, and then it's like greater than 120 will give you a 1. So now the condition is given afterwards. They say X is 1, shut down when any of these occurs. So we have to produce 1. How? Not S and T. So not S and T. What does it mean? Not S. Not S is was like this. So this thing. Okay. So less than 1000, as like they have mentioned over here, and is already given there, and T is like greater than 80, because they said, they didn't say it like it's or not. If it's not, then it's like 1 means like over here the condition will take this condition over here. Okay, S and W, they are very simple. S and W, S is 1, so it's greater than 1000, and W is greater than 120, so they have just mentioned it over here as well. Okay, and next one is not T and W. Not T will be like this one, because it's like a 0, and W is again 120, greater than 120, so that's how you'll get it. And in the final answer, the final expression will look something like this. And if you have, if you're able to make it, then again, you can, from here, you can make the expression, you can make the truth table, you can make the circuit diagram. So everything will work out from here. So, okay. So there are some possible questions given over here, the very same way. Okay. And yeah, so over here, that was the final complete review of chapter number 10. And if you have any confusion, you can ask me, and I have mentioned another video over there on top. Okay, you can see that in very detail, and I'm gonna solve past papers in another video. So if you like the video, so do what you want to do. Okay, thank you very much, and see you in the next video.